Sometime over the past year, I became aware of a series of videos produced by Matt Parker, who has the YouTube channels Numberphile and Stand Up Maths. His enthusiasm for math is so infectious that I decided to try replicating one of his experiments. In this case, we're going to measure pi using a pendulum. What does pi have to do with the period of a pendulum? It turns out the period is actually proportional to the square root of the ratio of the length of the pendulum arm to the acceleration due to gravity through the factor 2 pi. This assumes the pendulum bob is very heavy relative to the pendulum arm and that there's no friction at the pivot of the pendulum. We can set up an experiment where we choose our pendulum length so that the period ends up being convenient for our calculations. In Matt's original video that I watched, he set the pendulum period to be pi seconds long. What that means, if we work in American engineering units, is the pendulum arm needs to be about 8.05 feet long. This is a little bit inconvenient for a home experiment, so instead I looked at making a pendulum with a period of pi over 2 seconds. It turns out in that case the pendulum arm needs to be only 2.025 feet long. That's 2 feet 1/8 of an inch. That's quite doable at home. For 20 swings of this pendulum, it should take about 10 pi seconds, or 31.4 seconds. To build this, I worked with two constraints. First of all, I wanted to build it only with things I had on hand at home. And second, the video you see later in this video is actually my very first take trying out this pendulum. To build the pendulum, the first thing I did was made a template. I took 3 sheets of paper so that I could draw a line longer than the pendulum arm that I needed. And you can see on this sheet of paper that I've got 2 registration marks. Those marks are actually 2 feet 1/8 of an inch apart from each other. The washer will be the pendulum bob, the thread will be the pendulum arm, and I'll suspend the pendulum from the skewer in a convenient location. You can see here how I'm using the template. I've got the center of mass of the pendulum bob over one of my registration marks, and I've got the thread tied to the skewer at the other end, but you can see I didn't hit that registration mark exactly. That's so that I could actually roll the skewer up to the point I wanted. It gave me just one more degree of freedom to be a little bit more precise than had I tried to tie the string in location. Where else to suspend this but on my piano? You can see safety first. I've got the point of the skewer facing away from where people might walk by. Pendulum is suspended down. I've used a trumpet mouthpiece as a marker as the pendulum bob swings by. That will give me an objective mark so I don't have to guess where the middle of the swing is. For my trumpet playing friends, that's a Schilke 13C4 mouthpiece. I've measured the time using my iPhone. Because I'm doing this by myself, what I'm going to do in the video is start the timer, then start the pendulum. So I'll measure the start time for the first swing, count out the swings, and then I can catch the time at the end of the 20th swing. So let's go to video. You can see here I'm getting ready, set, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and I'm going to let it swing a few more times. If you wish, you can grab a couple more data points from this. Maybe your answer will be a little bit more precise than mine ended up being at the end of this video. So we'll let this swing its way out and move to our extremely complicated calculations. The first swing began at 4.9 seconds. The 20th swing ended at 36.47. So overall, my 20 swings, which was 10 pi seconds, took 31.57 seconds. So I get a value of pi of 3.157. This is actually within 0.5% of the true value of pi. So this turns out to be a pretty good experiment. With that, I'll bid you a happy Pi Day.